Hello, this is my birthday polynomial project on Luis E. Miramontes Cardenas. He was born on March 16, 1925, therefore his ordered birthday digits would be 3161925. The polynomial function I created from these digits was f of x equals negative 3x to the 6th power minus x to the 5th power plus 6x to the 4th power plus x to the 3rd power plus 9x to the 2nd power plus 2x plus 5. My table of values are color-coded as follows: green being possible zeros, pink being zeros, brown being the turning points, and blue being the y-intercept. And I got these values from doing synthetic division. How this graph relates to Miramontes. This graph relates to Miramontes because it has an M shape to it. And a lot of things in Miramontes' life started with M. He was born on March 16, 1925 in Tepic, Nayarit, Mexico. Also relating to his birthday, he was born on a Monday. He went to college and died in Mexico City. He was a Mexican chemist that invented prostogen noresterone, which is a hormone that is used in contraceptives. His last name is Miramontes. All of these proper nouns relating to his birthplace, place of death, location of where he attended college, surname, and birthday all start with M, and the graph has an M shape to it. Analyzing the polynomial, the degree is 6 and the leading coefficient is negative 3. The y-intercept is 5. There are two real zeros, which are negative 1.833 and 1.7196. There's a total of 3 local turning points and the end behavior is negative. As seen here, my turning points are negative 1.436, 23.04, negative 0.111, 4.888, and 1.313, 23.964. The y-intercept is 5, and the real zeros are negative 1.833, 0 and 1.72, 0. Elaboration of previous slide. My function has 2 real zeros. However, because its degree is 6, it should have 6 solutions. The reason we don't see all 6 depicted in the graph is because 4 of them are imaginary solutions, while negative 1.833 and 1.72 are 2 real solutions, which is why we see them on the graph. When I did synthetic division with my possible rational zeros, which were negative 2, negative 5 over 3, negative 1, 1, 5 over 3, and 2, I mainly focus on negative 2, negative 1, 1, and 2. The coordinates of these were negative 2, negative 35, and negative 1.667, 16.893. Since I saw that negative 2 and negative 35 was under the x-axis because y1 is negative and y2 is positive, and negative 1.667, 16.893 was above it, I concluded that my zero would be somewhere between negative 2 and negative 1, and surely it was. The same goes for 1 and 2. The coordinates for these were 2, negative 75 and 1, 19. Again, I concluded my second zero would be somewhere between 1 and 2, and again, it was. Elaboration on local turning points. I got the turning point from decimals, but as you could see from my graph, after the first zero and following it is the relative maximum, which is not the highest point, but it's a relatively high point in the polynomial. From there, the graph goes downhill and hits negative 0.111, 4.888, which is my graph's relative minimum, meaning that this is where it stops before going down for infinity as we see it in the bottom. And since the graph has no absolute minimum, the polynomial goes down, hence the negative infinity sign, both left and right. After the relative minimum, however, we do see a rise again on the coordinates 1.313, 23.964. This is the absolute maximum. The polynomial's graph does not go higher than this. And then, as mentioned And then, as mentioned before, after reaching the absolute maximum, the graph will proceed to go down for infinity. The end behavior in relationship with the degree. The end behavior of this graph ended in a fall. Since my leading coefficient was -3, aka negative, it told us that it would eventually go down. But since our degree was an even 6, this told us that the behavior of this graph was going to fall both left and right. Thank you for watching this presentation. Have a wonderful day. Goodbye.